Hi guys. So this is the first video in a series of, I suspect probably quite a few, where we're going to create a programming language from scratch. We're going to write the programming language in Xojo, and we're going to learn how a programming language is implemented. We're going to implement every line of code in Xojo, and then we're going to enjoy the fruits of our labour. Now, why are we doing this, you might ask? Well, as you probably know, I'm trying to teach people how to code with Xojo, and I have a playlist specifically aimed at complete beginners. But I've been getting a lot of positive feedback from people who know how to code in Xojo, but just they want tips and hints on how I do certain things in complex projects. And also, I think there's a lot to be gained from tackling a really complicated project step by step with Xojo to teach the wider Xojo audience how to use the tool to its best advantage. Now, why am I making a programming language? Well, I actually have a specific need for it, so it's good to do something that I actually need to use and put some YouTube videos out there. I'm working on a home automation project and I need a scripting language to call from Xojo. Now, I could use Xojo's built-in Xojo script, but for reasons that aren't important, it's not going to cut it. So I need to implement my own scripting language. I've done this before. I have written my own scripting language in Xojo called Roo. I will put a link in the description to the open source GitHub repo for Roo that you can peruse. Roo is good, it works. It's not perfect. It's definitely not very performant. It actually runs on what's called a tree walker via a tree walker interpreter, so it's pretty slow. And we're going to address that in our new programming language. And also the code I wrote then, I was just learning about programming languages, and it's a bit sloppy and a bit embarrassing, and I've learned a lot since then that I think I could do better. And also the syntax of Roo was a bit like Python. And actually, I want a scripting language that's very similar to Xojo, frankly. So we're going to do that. So this program language, as I think I just mentioned, is going to be called Objo because it's object-oriented. It's going to be dynamically typed. So that means you don't have to declare if a variable is an integer or a string. You just assign values to it, and you can change them as the program runs. It's going to be basic-like, so it will look a lot like Xojo. And hopefully it will be more performant than Roo because it's going to be running on a stack-based virtual machine that we're going to write from scratch in Xojo. So there's going to be a lot to do. There's a lot of components in a programming language, but I think it's going to be fun. Hopefully people will learn how programming languages work from this series, and also how to do these things in Xojo, because a lot of the tutorials or articles about creating a programming language are written in C or C# or many other languages, mostly because people are trying to make a new programming language that's super, super fast, and actually writing a language in Xojo is probably not the most sensible thing to do. But I think the scripting language will be perfectly fast enough for what we want it to do. And I think doing a tutorial like this in Xojo will help the Xojo community. So without any further ado, we need to move forwards. And before we start a new project, we need to talk a little bit about programming languages and, well, not what they are. We all know what a programming language is, but how they're structured. And I guess we'll just do that right now before we move on to getting my face into the corner and seeing some lines of code and various other things. So obviously, I'm sure you know what programming language is. I'm not going to teach you how to suck eggs. But how do we take a program that we write, which is essentially just a collection of characters, a long string, and make it do something? What happens? What's the pipeline? Well, there are a few key components in a programming language. The first thing that has to happen when you write your program is it has to be tokenized. So the characters have to be split up into what we call tokens, which are sort of the most basic atomic unit of code that you can think of. Now, by that, I mean it splits the characters that you write into numbers, strings, identifiers for, say, variable names, keywords in your language. It splits them up into those little units that we call tokens. And that is the job of the tokenizer, sometimes called a scanner. So we will have to write that first. Then once you've taken that and you've got a big long list of tokens that represent your program, we need to check that they make sense and that they are occur in an order that makes sense for our programming language. That's called parsing. And what parsing does is it looks at your grammar, which is something you also have to create for a programming language, and checks that, hey, does this make grammatical sense? Right? Are these tokens appearing in the correct order for a valid program? So if you imagine in Xojo, when you create a variable, let's say you have an integer called I, you would write var I as integer equals a value. Now, the parser will split that into a series of tokens, a var token, a token called I, which is an identifier, as, which is a keyword, integer, which is an object type, then an equals sign, then a value, okay? And then the parser has to look at it and say, does that make sense? You know, if I see the var token, what should I see next? Well, you should see an identifier next. And so the parser will check that that's true. And so we need to write a parser that will do that, that will look at the tokens that come in and will check that they're in a valid order. And it will also kind of bundle them up into little units which make semantic sense. So for instance, if you've got the line of code I just talked about, var I as integer equals 100, then that can be passed into a little unit which is basically a variable declaration. It says, okay, this line is a variable declaration, and this is the name of the variable, I, and this is the value it's going to get, 100. And that will be passed further down the tool chain for us to do something with. So that's the next step, parsing. Then sometimes there's a step called analysis, which is where you can have a program that makes grammatical sense but doesn't make any real sense. An example of that might be that if you imagine you write return, let's say you've got a method, and at the top of the method you just write continue. Now that's allowed. You're allowed to just write continue as a keyword in Xojo, but continue from what? It doesn't make sense if you're not in a loop, okay? And so the analysis phase, the analyzer will say, oh, okay, well, this is grammatically true, but it's nonsense. You can't continue from here. So we'll say that's an error. So, and also other things like optimization passes. So it might be that the analyzer can have a look at your code and be like, well, you're doing the same thing over and over and over and over again here. I can simplify this. And so it can alter the parsed tokens such that it's more efficient. That's an optional phase in a programming language. After that, you have, we will have, because of the implementation we're going to try, we need a compiler. Okay, so we need something that takes the output of the parser, these tokens, and essentially turns it into bytecode. Okay, now bytecode are instructions that our virtual machine, which we're going to write, will execute to do your program's bidding. So it might be that in your program you say, okay, var I as integer, or actually this is dynamically typed, so we don't need to specify as integer. We're not thinking like Xojo. Let's just say ours is var I equals 1 plus 2. Then what will happen is we need to turn that into a series of instructions that our virtual machine understands and can do. So we need to say, okay, turn that line of code into an instruction for adding 1 and 2 together and assigning the value, excuse me, and assigning the value to an integer, to a variable called I. Okay, so that's what the compiler has to do. And then when we've done that, we also, kind of concurrently at the same time, we need to write a virtual machine, a VM, an interpreter, whatever you want to call it, which will take bytecode, which is made by our compiler and run it, okay? Actually do something and spit out the answer to the screen for us. So they're the main components that we need to build. We need to build a tokenizer, a parser, a compiler and a virtual machine, and maybe an analyzer. It depends. That's not imperative. Now, before we can do any of that, we need to know what is our language supposed to look like. We have to make these decisions. How do you declare a variable? I'm thinking I want it to be var I equals 100. Okay, I want the word var to mean the variable is being declared, then an identifier, and then maybe an optional assignment, it equals something, or perhaps you just say var I. I'm just declaring a variable. But we need to come up with actually the rules of our language. I mean, that's important because we're going to implement it. And so in the next video, I'm going to talk through Objo's grammar, which is, I've already taken the time off camera to figure it out, something that should be easy to teach and also something that will work for ultimately my end goal that I need the scripting language to work for. So I'm going to leave it here, and next up we're going to come back, we're going to go over the grammar, and I'm going to try to explain to you the concept of a grammar, and then once we've got that under our head, we can start writing some code. Okay, right, so I've got a document I've prepared earlier, which is a grammar document. Now, essentially what this document does is it goes through all the different types of statements that Objo will allow, and unless we write this down in advance, we're going to end up making it up as we go along, which is just not a good idea, trust me. It's best to take the time and do this in advance. So I'm going to walk us through this document so we can get a feel for how we have to think as programming language inventors in order to carry on with this project. So there's a key here. Essentially, we have the concept in a grammar of terminals and non-terminals. Okay. Now these are symbols, and you can see here that in blue is a non-terminal symbol, and in green is a terminal symbol. Now, as I've helpfully written up here, terminals are endpoints. Okay, they are essentially tokens that we will produce in our tokenizer. Non-terminals essentially represent other rules in the grammar. Okay, and we'll come to that in just a moment. And then I've used a sort of regular expression type and nomenclature here as well. So anything put in, you can group things in brackets. A pipe symbol means a logical OR, and then a star means a rule can occur. It can be optional, or can occur any number of times. A plus sign means that the group can occur has to occur at least once, but can occur many times. And a question mark means that it's optional. It can occur at most once, but might not occur at all. So an Objo program is essentially just a collection of declarations, all right? So it's a collection of variable declarations, class declarations, and other statements. So the topmost level of our grammar is a program. And that's made up of multiple declarations. You can see you've got declaration and a star. That means, well, 0 or more. Because technically a program could just be empty and do nothing. So then what we do to figure out this grammar is we say, okay, declaration, where's the declaration rule? Here's the declaration rule, okay? And as I've sort of described here, declarations are statements that basically either bind an identifier, and by identifier I mean like a named variable, so a class name, a function name, or a variable name, or any other type of statement. So a declaration is one of these 4 different types of rules: a variable declaration, a function declaration, a class declaration, or a statement. The Objo isn't going to support modules at this stage. That's something we could think to add later, but at the moment we're going to keep it simple. So, okay, right, what's a variable declaration? What does that look like in our language? Well, it is a var token. Okay, it's capital letters in green, so that means it's a terminal, which means it's a token. Okay, so to declare a variable, we need the word var, then an identifier. Okay, so that might be, name, Gary, age, score, whatever our tokenizer determines is an identifier is what is expected next. Then I've put here, we're going to allow you to define multiple variables on a line. So in brackets, I've got an optional, as many as you like, comma, followed by another identifier. So that would let us do things like var a, comma b, comma c. So declare 3 variables at the same time. Then if you want, you can do an assignment at the same time. So I can say, okay, this variable's initial value is going to be 100. So to do that, I put in brackets an optional, at most one time, but possibly no times, an equal sign, and then an expression. Now an expression, if we come down in the grammar, is something that produces a value. Okay, so what we're saying here is that you can, if you have the keyword var, then an identifier, then an equal sign, it has to equal something that produces a value. So that could be retrieving the value from a variable, it could be a constant like the number 100, or it could be a computation like 10 plus 10. All right. And then we end it with this funny thing called a terminator. Now it's blue, it's a non-terminal. So what does that mean? Well, we'll find where the terminator rule is. What is the terminator rule? Okay, it is one of these 2 tokens. It's an end of line token, so a carriage return, or an end of file. Now, end of file is going to be a special token that our tokenizer will spit out when it gets to the end of the script file. Okay. So that's how you declare a variable, and the grammar goes through like that, and you can peruse this at your own leisure if you like. I mean, this is all in the repo, the description of which is in the link to which is in the description. But we'll just look at a few more. So function declaration. So if we want to declare a function, not a method in a class, but an actual function, that will require the keyword function. And then we've got another rule here called method. We'll get to that in a sec. And then end function and then a terminator. So what's this method malarkey, and why have I written method here and not just the tokens that are required? Well, if we scroll down and find method, which is down here in the helper bit, you'll see that a method is an identifier token, then a left bracket, a variable number of parameters, closing bracket, end of line, and then a block. Okay, what the hell? What's a block? Well, again, we've got to find the rule in the grammar. You can look at this document yourself, but a block is a collection of statements. And these are the statements that our language allows, okay? A statement can be a block of code, which is essentially just more statements. It can be a break statement, so that's going to let us drop into a debugger. Continue, like the continue keyword in Xojo. A do loop, exit statement, an if construct, so if, else, one of those. A for loop. We're going to hard code in a print statement because until we get classes up and running and functions up and running, we're not going to have any way of showing what our language is doing without an actual keyword to let you print something. So we're going to have a print statement, a quit statement to end the script, a return statement which will bring us out of a function, a select case statement we're going to do, a while loop, and then this funny thing called an expression statement. Now what's an expression statement? Well, an expression statement is essentially just an expression, something that produces a value, followed by a terminator, okay, followed by a new line. And the reason that we need that will become apparent as we develop the language, okay? And we'll just pick one of these statements rather than going through them all. Let's pick the while statement. So if I find the rule for a while statement, you can see it's the while keyword, then an expression. So in Xojo, you can imagine if we have a while loop, we might do while score is greater than 10. Then some code, wend. So we have the same here, expressed in a grammar. While some expression, some value, okay. Now our VM will make sure that that value evaluates to true. But while some expression happens, we have a new line, then a block, which if we go back up, we can see that a block is just a list of statements, just a list of stuff to do. Okay. Then wend, then a terminator. Okay. We'll take a little look at the expressions. We're going to get to these in details when we actually implement our parser. Don't worry, I'm doing this really quickly, deliberately, but we will cover them when we write the parser. I've written them in this way to make it as easy as possible for us to write a parser. So now expressions, as I mentioned, they produce values, okay? Now, I'm going to be absolutely honest. This will take a while for you to get your head around and will become much more apparent when we are writing the parser. Trust me, I think this makes sense. But in essence, this is like a cascading rule set. So the top level expression looks at the assignment rule. An assignment rule then says, okay, does the token that we can see coming up next match the nil coalesce rule, which is, sorry, I'm just going to change that to coalesce. Does it match, just make that the right color. There we go. Does it match this rule followed by these tokens? Okay. If it does, it keeps cascading down, recursively down through these rules to build up our parse tree, okay, which we will get to when we're writing parsers. In essence, the rules at the top here are the lowest precedence. So if you remember when we think of simple mathematics, and we know that multiplication and division has a higher precedence than addition and subtraction. Because if I tell you what is 1 plus 2 times 5, the answer is 11. Because what happens is the 2 and the 5 multiply together first and the 1 is added. Okay, that's just how we have established the rules of precedence for maths. Okay, now I could change that by having a bracket 1 plus 2 close brackets times 5. Then the answer will be 15. Okay, but it's all about precedence, and that's the same in programming languages. Certain things have a higher precedence than others. And so in this list, the ones at the top have the lowest precedence and the ones at the bottom have the strongest, highest precedence. Okay, so you can see here the multiplication rule is below the addition rule. Okay, because multiplication has a higher precedence than addition. It's complicated slightly because of convention to how grammars are written, that actually in the multiplication rule we actually have a slash, which is division sign, a star, the multiplication sign, and the mod keyword. So it actually, although it says multiplication, it's kind of multiplication and division and modulo. But I'm trying to keep it as close to normal grammar convention as possible. But like I say, this is very complicated. I'm not expecting you to take this all in at this go. I just want to quickly whistle through this document so you have an understanding of how I've written it, because we're going to be using this document an awful lot when we write our language. And then at the bottom of the document, I've got a few helpers, okay, which they're just basically shorthand versions of the rules. So that's our grammar. Now, I'm not going to go into more detail than that at this point. We will cover it again when we get to writing the parser. But the next thing we need to do is write the tokenizer. Okay, now that should be fun. So the next video will be us spinning up a new project and doing just that. Now, the repo is open source, so you'll be able to follow along. This is a Pages document, but I'm going to make it a PDF as well, so if you're not on Mac, you can still read it. Okay, I hope you found this interesting. Perhaps it's whet your appetite, and I'm excited to get this project moving forwards.